Hello. Today's video involves more antidifferentiation or integration, and we're going to look at some examples that involve multiple methods all in the same problem. Let's start off with ln cubed of x over x plus 3 over 5 cube roots of x dx. Now, the second part of this you should recognize is just a basic power, and so we can use the reverse power rule. The first part of this, however, requires substitution. And so because this involves two different types of things that we're doing, one's basic, one's substitution, so it's not basic at this point, the first thing I'm going to do is break this apart and write this as two separate integrals. We can do this. We can break apart over addition and subtraction, not multiplication and division. The integral of f of x plus g of x dx is equal to the integral of f of x dx plus the integral of g of x dx. However, the integral of f of x times g of x, or divided either way, does not equal the integral of f of x times the integral of g of x. Please do not do this. Okay? You can break apart over addition, subtraction, not multiplication or division. So, now for this first piece, I can use u sub. U is ln of x. Du is 1 over x dx. This works nicely. This becomes the integral of u cubed du. I'll finish this out. So this is 1/4 u to the 4th. And so then this becomes 1/4 ln to the 4th. ln of x to the 4th. Now I'll deal with this piece. This one I'm going to rewrite as 3/5 x to the negative 1/3. The antiderivative of that then is, using reverse power, add 1, take the reciprocal, and I'll throw in the plus c, and so then I get plus 9/10 x to the 2/3 plus c, and this is my overall final antiderivative. Okay, suppose I have the example integral cosine cubed of x over 3 sine x. And in this case, I'm going to write this as the cosine cubed, I'm going to break apart as cosine squared of x times cosine x over 3 sine x. And then use trig. Cosine squared of x is 1 minus sine squared of x. So this becomes 1 minus sine squared of x times cosine of x over 3 sine x. And at this point, I'm going to pull the 1/3 out because it's just be easier that way. This becomes then cosine of x over sine x minus sine squared of x cosine of x over sine x. When I distribute the cosine, and the sine goes to each of the individual pieces, or that gives me then 1/3 the integral of cotangent of x minus, and when I reduce this, sine x cosine of x. Now again, at this point, cotangent is a basic form. Sine x cosine of x requires u sub. And so at this point, I will break this apart. 1/3 the integral of cotangent of x dx minus 1/3 the integral of sine x cosine of x dx. Okay? First one, 1/3 natural log absolute value of sine of x. Again, those are basic form, pretty simple. For the second piece of this, u is sine of x, du is cosine of x dx. And so this becomes minus 1/3 the integral of u du. This I'm going to just bring down for the moment. Work on this side only. This is 1/3 times 1/2 u squared plus c. And then I'll rewrite this. My final result, 1/3 natural log absolute value of sine of x minus 1/6 sine squared of x plus c. Okay? My last example. Well, it's an example and a half, if that's possible, I suppose. I'm going to give you one that I'm not going to do, and then I'm going to do the one that I am going to do. If I have ln of x over x, ln squared of x plus 2 dx is the one I'm not going to actually finish. In this case, my u would be ln squared of x plus 2. Because then my derivative of this would be, this is a power with the chain involved. The derivative of ln squared of x is 2 ln of x over x dx, and you notice that this basically matches everything else that I have here. And so then I would get 1/2 du is ln of x over x dx. And then making the substitution, we would end up with 1 over u times 1/2 du. And at that point, this is pretty simple. I suppose I might as well just go ahead and finish it. I guess I'll do 2 more examples. 1/2 natural log absolute value of u plus c, 1/2 natural log absolute value of, in this case for u was ln squared of x plus 2 plus c. This would be my final result. This is just basic u sub, not really 2 things involved. The problem that I really want to do that involves actually multiple methods in the same problem is ln of x minus 9. And this was actually in the solved problem set. And in this case, my u is not ln squared of x plus 2. That won't work. I'm still going to start with a u sub, but now my u is just ln of x. My du is 1 over x dx. Notice that that will get, I can then replace this as u squared plus 2. I can replace the 1 over x dx in the denominator. The ln of x, I will also use the u up there. And so now this becomes u minus 9 over u squared plus 2 du. Now, at this point, that's a little bit nicer than what we had, but it's still kind of ugly. I will break this apart as u over u squared plus 2 minus 9 over u squared plus 2. And the reason why I want to do that is the first piece is a u sub, the second piece is a basic form. Since I already have a u, I'm actually going to have to use a different letter. I'm going to call it a v sub. And so let's first write this as two separate integrals. U over u squared plus 2 du, minus integral 9 over u squared plus 2 du. In the first case, I'm going to let v be u squared, dv is 2u du, or 1/2 dv is equal to u du. Well, I wish I could write. This becomes then 1 over v times 1/2 dv. I'll go ahead and finish this piece. 1/2 natural log absolute value of v. I then replace 1/2 natural log absolute value of, my v is not u squared, it's u squared plus 2, and it doesn't change my dv. 1/2 natural log of u squared plus 2, and then going back all the way, this becomes 1/2 natural log absolute value of natural log squared of x plus 2. Over on this side, as I mentioned, this is a basic form, and so I can just go ahead and take the antiderivative of that directly, well, in terms of u, so let me go up one. This is minus 9 over the square root of 2 arctan of u over the square root of 2. All right, 1 over u squared plus 2, that's your arctan antiderivative. And so then this becomes negative 9 over the square root of 2 arctan of u we said was ln of x over the square root of 2 plus c. And this is your final antiderivative.